Hello everyone. This will be part 2 of our command and service module tutorials we got going on. So for this part, because this checklist procedure is really long, we're going to display the checklist. And just remember, we're not really going to be talking about the systems on here until we interact with them in flight, just because that'll give it a lot more context. I'm gonna give like a brief overview, but we'll talk more in flight. This video is just guiding you through the backup crew pre-launch checklist, which is a really long one. So we'll go ahead and I'll actually pull the checklist up for you. You should be able to see it in the corner. Now you can use your own paper checklists. They'll have more writing than your standard built-in checklist, but the built-in checklist is the exact same, just without all those, warning labels and stuff. They are in when required, but you won't find them here. So we'll go ahead and run the sim, and we'll just let the checklist go until it comes to a stop. We should see that caution warning, power to 2. So I'll go ahead and get the integral lighting on so that you can better see what exactly we are interfacing with, just because I know that in the pre-launch configuration with the lighting, it can be really difficult to see. So we'll go ahead and turn the integrals all the way up. We'll do caution warning power to 2, so just to test. Make sure we got all 3 lights. Just a test of the caution warning system. Now we'll test the lamps. So if you left click and you press shift and then you release left click, you can hold it down. That allows you to unmouse. So we should see the left light here. And if we go to boost, we should stop seeing this master alarm light. And the reason this stops is because the red from the abort light is the same red as the master alarm. So the master alarm light could be confused for an abort light. And since every light on this panel brings a master alarm, even though it may not be, like a super critical thing, like O2 flow high or something like that, you don't want to confuse that for an abort, and necessarily put a mission or yourself at risk. It's following the same thing. We go back to normal, make sure the light's back on, and then we go to lamp test 2, ensuring the left bank is off and the right bank is on. We should see the right light, no center, and no left lights. We can release, and then go to boost. The entry monitoring system here, this is used for monitoring delta V and entry. Just a brief overview. Right-clicking on the switch location. So switch is located here if you're having trouble with that. It's not going to work anywhere else. But this is the GTA, the ground test accelerometer. Only time you ever need it's on the ground. We need to subtract Earth's gravity from the measurement system, so we do that with that switch. We'll wait 10 seconds, and basically we should see, as you can see, a delta V indication change of less than 0.1 per 10 seconds. If we do get an issue, we will have to report that to the ground so that it can be compensated for flight. We'll go ahead and set delta V. You can set it using the thumb wheel. Set it to plus 1586.8. And now we just run it through, right-clicking to delta V test. And we should see the number go down. And it will thrust out at negative 0.01 or negative 0.1 feet per second. We'll get the SPS thrust light turning off. And then we'll just verify that it stops between negative 20.8 plus or minus 20.7 FPS. We do get a little bit of a discrepancy here. don't worry about that small discrepancy. It's I don't know why it is, but it's not an issue. If you ever get that. And in space, I don't think I've ever gotten any discrepancy that I can recall, but basically if it's a little bit over, it should be fine. Take her to standby and come to test 1. Now this is our entry monitoring system tests for the actual entry testing. The delta V monitor is just a delta V counter with SPS cutoff capabilities, backup for the computer. Here we'll actually be testing out the different entry monitoring. So firstly, we set EMS test to 1 and normal, and we just make sure all of our indicator lights are off. And then we'll use the thumb tilt switch to make sure that the yellow line is in between these two black notches. And then we run test 2. After 10 seconds, we should see the 0.05 G light with all other lights off, just as the checklist states. We get the light, and we go to test 3. Now on test 3, it will be the 0.05 G light will stay on, and then we'll get the lift vector down light. While we wait for that, we can set our range to 58 nautical miles. A little tip here, right-clicking will allow you to increment it in small amounts. We could see lift vector down light. So run to test 4. We'll watch the scribe, make sure it does the full pattern, and once it reaches the bottom, the most important thing is making sure it stops at 0 and in between the two lines. We get a very small discrepancy, but it is within plus or minus 0.2 nautical miles, so it is a completely nominal discrepancy. Running to test 5, we'll get the scribe vertically tracing all the way up to 9 Gs, from 9 Gs to 0.28 Gs, and then it stops within that test pattern, and then we get the lift vector up light. So 0 G is up at the top, and 9 G is down at the bottom, 9 being the max that is readable on the EMS. Going to range set, the scribe will go all the way up to 0 G, plus or minus 0.1 G, and all lights will be out. You can take it to standby, left click all the way down to off. Don't go backwards through EMS tests, just go all the way around. And then you can turn the switch off and close the cover, or you could simply just right click to close the cover, and that will also automatically turn your switch off. That completes the EMS test. We'll now run the glycol loop test. So secondary glycol loop test, we will want the secondary valve to normal. There are 2 ways to get there. Firstly, the actual way, control down, control alt, here, left brings us to that panel, control alt up, and you can click it here, or from your seat, you can go up to the window, turn around, and click it like that as well. And that's sort of the fake way, but a little bit quicker if you want to do it that way. Now you'll set your environmental control system indicator knob to secondary, and you'll see everything with an applicable secondary will switch over. Everything that only monitors primary will obviously stay the same. So all of the glycol has a secondary, as you can see, primary, secondary, and then that covers the entire line here. This has a secondary. This is obviously the secondary separate from the primary, so clicking that doesn't change anything. And then, of course, we've got our accumulator, primary and secondary, so the left needle here has a change as well. Taking the secondary cooling pump to AC bus 1, we want to monitor our glycol discharge pressure, and that shows the pressure on the discharge side of the pump. We will, excuse me, go ahead and turn auto off real quick. Get that back. All right, so taking a look, discharge pressure should rise to about that much, 39 to 51. We'll see it has it run through a couple more checks here. So temperature, ECS radiator temp, secondary inlet. So here's our temperature, here's inlet, secondary. Should show 60 to 97, so between here, and we're good. Secondary outlet should be between 60 and 70. Here's let's see, ECS radiator temp, secondary outlet. Yep, here we go. Between 60 and 70 pegged. We are not between 60 and 70, but this discrepancy is fine. Secondary glycol evap temp out. So here we go. Glycol evaporator temperature outlet. We've got the secondary. And this should be, again, between 60 and 75. This discrepancy is fine. Secondary glycol evaporator steam pressure indicator. So here we go, steam pressure. And this should be 0.25 or near that, meaning we're not boiling right now. We don't have the evaporator turned on, and we wouldn't be boiling anyways as we're not in space. Lastly, we did already check the glycol discharge pressure. Lastly, we would just make sure that the accumulator, when we turn it on, didn't go down too much. So it should be between 39 and 51, and that it is exactly at 51, so we are good. The accumulator is responsible for making sure that the line doesn't form voids when the pump turns on, as the pump can suck, and it takes time for the discharge pressure to equal the suction. So again, you saw that needle rise very fast, but it's not instantaneous. So because of that, when you're in space, you can get a gap between the suction end of the pump and the discharge end of the pump, and you can end up running the pump dry and breaking it. So because of that, there is a very, very tiny additional reservoir, which is held under pressure. And that basically is on the suction end of the pump. So when the pump turns on, that under pressure reservoir of glycol shoots down to make up for those voids. So you'll see a slight drop in this as the discharge pressure comes up, and once the pressure stabilizes, you'll see the accumulator stop dropping. Then as the whole motion of fluid has had a chance to translate through the entire line and back into itself. So a little bit of an in-depth explanation there, but it's perfectly applicable at this point. Secondary cooling pump to AC2, and we just check that it holds pressure. And then we turn the pump off. We can see the pump actually slowly discharge, or slowly come down. And as the pump begins to roll to a stop, its discharge pressure will come down as well. Take auto back on. Switch back to primary indicators, and we'll go ahead and bypass the secondary to radiators. We'll now activate the primary loop at this point. Primary loop has been running on ground supply, running on like a ground support equipment. So as soon as we activate a pump in the spacecraft, that ground support equipment will trip out. My theory on this, I don't actually know why, but my theory is that the additional pressure, the pressure will spike for a split second because both pumps are running at the same time. That pressure spike will cause a ground support equipment to trip out. And once it does that, then the spacecraft's entirely on its own pump. So if you were to flip it to 2, like pump 2 or pump 1 and back to off, then it will not be sustained by that ground support equipment anymore. So just keep that in mind. Spacecraft cooling, even on the ground, it's incredibly important. So clicking it to 2, AC1, we'll see discharge pressure remains stable. That ground support equipment is now tripped offline. We'll go to pump 1, AC1, and verify that the pressure remains stable. So we've got 2 good working pumps. We'll go ahead, radiator flow control power to power, and then the auto flow controller to its secondary controller. we could see the secondary controller talkback is on, verifying that the changeover logic does work, and we'll set her back to auto and to off. Now I'll open DirectO2 just past the halfway point and verifying that it goes to 0.4 plus or minus 0.11 or 0.11. I have problems with the transducer not being able to read right away, so just trust me on it. If you have the same thing, 2 clicks is perfect. Okay, now we're up to the standby inverter check. Standby inverter, that's just inverter number 3 here. We can see the sunrise coming in through the spacecraft. Setting AC to reset switch. This is sort of part of the sensing circuitry. So when it's off, if we unpower AC bus 2, we will not get a master alarm. But as soon as we go to reset, we would get that master alarm. So we'll take it off. We'll set inverter 3 to main bus B. So we either tie the inlet power, which is DC, to main bus A or main bus B. That inverter will then start generating alternating current. We'll take inverter 3 to AC bus 2 to test it out. So we'll turn off inverter 2. Inverter 2 is tied to AC bus 2, that is. So the inverter remains powered with DC, but it is not feeding any bus with AC power. We'll then tie inverter 3 to AC bus 2 and reset sensing circuitry, and we'll get the alarm. But because because inverter 3 works, that alarm is immediately cleared and the light is turned off. We still get the audible tone though. Going to AC bus 2, we'll just make sure that the 3 phases show the same voltage. And then we'll just do the same thing in reverse here, just switching back to the nominal configuration. And this time we'll test both AC bus 1, 3 phases, and AC bus 2, 3 phases. Taking caution and warning to acknowledge. With it on acknowledge, the master alarm can still go off, but the light will not come on. If you'd like to see the light, simply hold the master alarm, and a sort of dim version of the light will come on if it's in alarmed condition. This is just a means of making sure that nuisance alarms don't show up, or nuisance lights don't show up, as in the case of like in the ground testing, but you still want that tone to be able to check the lights, but it's also for saving power. They used it to save power in 13, so they could check the lights, but the lights wouldn't remain powered all the time. We'll now verify we've got our 3 fuel cell radiators. Talkbacks are gray, so they're in normal, not emergency bypass. If they were in bypass, you'd see barber pole, so make sure they're normal. And then we will open the 3 fuel cell radiator circuit breakers, preventing you from, emergency bypassing the fuel cells on accident. We'll do our float bag check. The float bag is part of the uprighting system after landing. If you enter in stable 2 position, you'll just get righted with stable 1. We've all seen those balloons on the spacecraft, basically. Airbags, that's what those are for. So you take them to off, close the circuit breakers, take them to vent, and then checklist tells you to open them right away. I believe the spacecraft test conductor would tell you that you're clear to test and you can open those circuit breakers. Coming down, checklist auto proceed past some stuff which is already complete. We'll come over here, right click in this anywhere on the sort of meshy area here to open the coolant control attenuation panel, and just make sure that all of these are set correctly. Okay, did accidentally change a knob here, but I think I unchanged it, so that's good. All right, take us to LMCM delta pressure. Now here's the thing. It should show 0, obviously, because we're on the ground, and the LEMS pressure dump valve is open, so it's equalized. We're all equalized with a ground pressure. Our hatch is open. Their hatch is effectively open. We're all equalized. But because of the way that the simulation works, the pressure in a tunnel has to be like a separate tank. So the PSI difference is full right now, just because of the way it's simulated. Don't worry about that. In real life, it would be 0. It's a sim. So there's some things that just simply just don't display right, and that's one of those things. So rendezvous transponder power in its heater position. So heater only power, I believe, would run to heater and a power, and this heater only is to preheat it. Come down to the lower equipment bay. When you're here, simple Control Alt left brings you over to System Test Panel. There should be a way to be able to see the clock. I guess not. So just come over here, zoom in. Reset mission timer, and then it should show 0 and start, and it'll count up. Don't worry that it is counting up. That's normal. The central timing equipment, when it receives the liftoff signal, will automatically reset and start to count on the event time or on the mission timers again. So don't worry about that. Take it to stop on the event timer, then center, and then event timer reset. Now we'll come over here and we'll run a test for 5 alpha. Should show 1.1 to 1.9. Now we'll go to Bravo. We'll take the heaters here for our wastewater and urine dump ducts heaters to main, or to heater A, that is. We got a heater A and heater B. Now they're going to have us verify a couple of circuit breakers over here, namely the telecom panel and the fuel cell circuit breakers here. The only one we would have to do if we didn't click anything would be the lighting, coas, tunnel, rendezvous, spotlight, main bus B, open that circuit breaker. Okay. Now at this point, we can take the overboard battery vent to close and waste stowage to vent. Or waste stowage also to close, my bad. So both are closed. Ordeal is currently going to be unmounted as we are not in orbit. We don't want it mounted for launch, so we'll go ahead and click that yellow tab there. We'll unmount the orbit rate display, or 10 lunar. Now we're just going through verifying some of these. The switches I accidentally touched before when I was phase clicking through the panel. Repress package should be on, so there we go. Making sure our post-landing systems are all safed. And making sure our auto RCS is all set off. Floodlights to 1. Fixed is off. All this we can leave alone. The sequential events control system, or sex logic, 1 and 2 are off, and the pyro arms are safed. We'll go ahead and we'll close the service propulsion system pitch and yaw ties to battery A. And we don't have a docking probe on Apollo 7, so we will open dock probe main A, main B. This wouldn't be here in Apollo 7's actual cockpit, but right now it's sort of the unified cockpit copy of 11, if I remember correctly. There will be changes in NASP 9 that make different cockpits for all the missions, so stand by for that. So if you see that, you're like, where are those docking probe circuit breakers? If you're following this in the future, there may not be any. So just keep that in mind as things update and change. I will have to update and change these videos, so let me know if there's some discrepancy you want fixed. FDI GPI power to both. Logic to 3. SCS electronics power to GDC ECA. We'll get our signal conditioner and driver bias. 1 goes to AC1 and 2 goes to AC2. Just in case we lose an AC bus, we won't lose full power to our conditioner there. It does switch position verification for the control system. Translational hand control power to on, so that's translational control power on. And rotational control power normal to AC and DC cross time. And your directs will be off. All BMAGs are in rate 0. Zero on the trim. Make sure these are set right. All of these are set right. Center of gravity here for the delta V counter set right. All of these are safed and off except for the auto, which should just be on auto. The two-way switch between auto and manual. Launch vehicle indicator is to gimbal position indicator. We'll see the indicator here to change to its central position with a trim of 0. That makes sense. Event timer will go ahead and reset. And it spring loads back to center. O2 flow hasn't been affected yet. Like I said, I have troubles with that. So if you can't get it, 2 clicks and eventually it'll come up. But you'll just have to trust me on that. Uplink telemetry command module to accept. Instrument unit will be block. Service module RCS indicator to propellant quantity. So here we go. And I will run our RCS status check. So making sure all of our helium and propellants are Barber pole. And we'll open up the secondary propellant fuel pressure. I have to excuse my mouse there. Oops. Now we'll click through and make sure that our package temperature is ambient. Our helium pressure should be 4,000 to 4,350. We're at about 4,100, I would almost call that. And then our secondary fuel pressure should be at about secondary fuel pressure should be 192 to 207. 192 to 207. Yep, that's good. And then making sure that the quantity is, of course, all at 100%. And the last one, helium tank temperature. We'll go ahead and click through that one. 60 to 80 is what we're looking for right now. Here's 50. There's 75. So pretty much anywhere between here and here. And it's looking pretty good. Heater is off. We'll open the command module RCS propellant lines. And we'll verify that they meet pre-pressurization conditions, which is helium temperature 60 to 90. Helium pressure should be 4,000 to 4,450. And the RCS manifold pressure should be 80 to 105 on both quads. Eventually, you will just memorize the needle positions and be like, yep, that meets pre-press conditions, and we're good. We'll RCS command transfer to service module, just in case at some point in the ground testing it was CM. We don't want to fire CM thrusters when we get to orbit, so we do this ahead of time. We'll go through and check a bunch of switches. Just let it run its course here. This is the panel it is referring to now. We want to make sure repress O2 valve is closed, emergency O2 valve is closed, and the pressure gauge is greater than 865. Okay, so we've come up to a stop here. Integral lighting would normally be off on the right-hand side. However, due to YouTube being able to not read things when it's dark, we will leave those on for the time being. Again, no lunar module. In fact, these circuit breakers weren't even in Apollo 7, so we will go ahead and open the LEM power bus. It's going through, checking our fuel cell switch positions, our inline heaters, our radiator talkbacks, our pH, temperature talkbacks, and of course the bus ties. So we'll go ahead and tie fuel cell 1 to main bus A. So the buses are the horizontal and the ties are vertical. So we've got main bus A here with its sensing circuitry switch. We've got main bus B here with its sensing circuitry switch. So we tie fuel cell 1 to main bus A, spring loaded, so make sure to hold it down. I like to hold it down until the talkback goes full gray. And again, we could see 2 is tied, but we'll go ahead and tie it again just in case. As we know, it is possible for flag discrepancy. So just making sure we do it even though it looks like it's already done. Tie fuel cell 2 to main bus B. So now fuel cell 2 is cross-tied, producing power for both main bus A and main bus B. With fuel cell 3 being on main bus B now. We'll go ahead and click through, ensuring good flows. And we haven't gotten transferred to ground power, so the flow rate will be super low. So just make sure you check the skin temperature and the condensate exchange temperature. The flows are going to be obviously really low with nothing to power, as we're on GPU power right now. We'll go ahead and check between 5 and 20 amps for all 3 fuel cells, and that's good. Main bus A and B should be 26.5 to 31 volts. Notice no amp readout for any of the rest of the stuff here, except for the battery charger. Main bus B should be the same. Bat bus A, B, and C should show 35 to 37.5. We got about 36, about 36, about 36. That's good. Pyrobats 36 to 37.5, slightly higher because they're non-rechargeable. And back to main A. Verifying our inverter switch positions now, and then it'll just have you run through and double check the volts on the inverters again. SPS stat check. So it's going to have you run through, double check the temperature of the propellant tank and our helium pressure, as well as our fuel and oxidizer pressure. So green and green, about here and about here. It'll have you double check the injectors are closed, the fuel and oxidizer quantity, as well as the unbalance. Oxidizer flow should be max at this time. Then it'll have you double check the nitrogen for the valve actuation. And back to helium. SPS helium valves should show barber pole and be in the auto position as well. Once you get to this point where you've checked all that, uplink telemetry command reset, then off. Verifying power amplifier tape motion barber pole. Verifying the VHF is off. Fuel cell react valves normal. And then the tape recorder, we'll go rewind, verify talkback gray, and back to off. PCM bitrate should be high. We'll switch it to low actually for later on during the launch just to prevent some lag. With PCM bitrate to high, it is possible for lag to happen on certain systems and hardware that you may be running, so setting it to off just as a good overall measure for every person that plays. Mission timer, reset, then start. Verify, counting up from 0. Let the system run through. Okay, double check our our hydrogen and oxygen pressure, our quantities on all of the tanks. Go to the surge tank, verify that the pressure is also in the green, and back to tank 1. Again, everything 100%. Verify cabin fans off, and set your heaters and fans to auto cycle. And your O2 pressure indicator back to surge tank. It's going to have you go through and run the double checking of all of these. Instrumentation, it should be about the same as when we did the radiator leak check, but for the primary loop instance. So you can go ahead and look at the checklist for that on your own, or simply just double check that the needles are about the same as mine. It'll have you go through and check your suit compressor and accumulator as well as your H2O quantity. Potable water should be about 50, or excuse me, about we call that about 75, with waste being about 45. Now I'll run a test of our heat exchanger. So suit heat exchanger, manual on for 20 seconds. We can go ahead and just time skip through that a little bit. Then off. Secondary coolant loop will go to reset for 58 seconds. Resetting its valve position to the off position. Yep, then off. We'll go ahead and adjust the steam pressure valve to its off position. This one doesn't have a reset like the other one does. Don't ask me why. So just going ahead and increasing it for 58 seconds. We can go ahead, hold that down, do some time skipping. And that will basically hard over the valve. Back to decrease 2, 3, 4, 5, 6, 7, 8, then off. And that sets it back to its regular position. So you hard over the valve, then you just gently close it. We'll go ahead and activate the comms. So our S-band, unified S-band transponder to primary, power amplifier to high, and after 90 seconds, we will go ahead and see the power amplifier talkback as a power amplifier, and the traveling wave tubes are powered up, and our comm system will be activated at that point in time. There we go. VHF B will be duplex. For those who don't know, duplex basically means that the system can encode 2 pieces of information simultaneously. whereas simplex can only do one. So simplex would be like a radio. It can talk, but it can't also listen at the same time on a walkie-talkie, right? And then you get duplex. That would allow you to basically um, talk while listening on the same thing, or even talk but share two different pieces of information, or receive two different pieces of information. So duplexing is really, really handy. Of course, if you have a separate transmitter and receiver, you don't have to worry about, duplexing to talk and listen at the same time. Here, the duplexing would be for ranging information and voice information, or data and voice, so we have a transmitter and a receiver separate. So very nice there. Okay. We'll get everyone's, excuse me, wrong side. Get everyone's comms turned on and checked out. So first the CDR side. Power audio tone, super power on. Double check everything here shows 5. Good. VHF ranging should be in its normal position. In Apollo 7, this wasn't even a switch. So again, don't worry about it if in the future it doesn't exist. Here we have the CMP panel, power audio tone, suit power on. And lastly, the lunar module pilot, power audio tone, and suit power on. They'll then run some comm checks from the ground. At the completion of all of those checks, go ahead and turn off those very same switches. Let's hear suit power audio tone. Then go ahead and come to the CMP, since it's a little hard for the CMP to hear between two people and stuff. We'll go ahead and increase master comm, intercom, and S-band. VHF should have 2 increases to 7. Caution warning power will go to off, and you will open the circuit breaker caution warning, main A and main B, turning it completely off and egressing the spacecraft. The final part of this checklist is going to be the prime crew pre-ingress procedures. Go ahead and time skip to T-minus 3 hours. And again, you usually don't want to do above times 10 on the ground. If your computer can handle it, you can. Just make sure you set PCM bitrate to low. With PCM bitrate to high, you should not be time accelerating anything past times 10, even in space. So just make sure, if you want to do some high time acceleration, make sure all of your bit rates are low in both your LEM and your CM. If the LEM hasn't been powered up yet, then it's of course not a problem, as there's no power to the comm system, so there is no bit rate at all. Pre-ingress procedures. We'll turn off the comms. We'll go ahead and close the caution warning, that is. Excuse me, used to calling it CW like the LEM. To boost, and to 1. We'll open our potable tank inlet valve. That is down here. I am not on the virtual cockpit branch, so none of this panel is in for me yet in 3D. But if you are, good for you. Congratulations. Enjoy it. I'll get it eventually. If you come here, you can either have the checklist do this for you, or just come in 2D and just click them. And that should open up like the water systems that test it out. And I believe, don't quote me on it, but I believe it also breaks open a seal. So that when it was on the ground, it wouldn't leak. And turning that knob then breaks open that seal. You can see direct O2, adjust to 0.6 to 0.8. See, I told you, 2 clicks is the perfect position, but it wants you to go full open and then back down. So you can go ahead and do that. Our O2 flow is perfect. Suit compressor to AC1. So suit circuit. Hydrogen accumulator. Just having to remember, yes, suit compressor over here. Suit compressor number 1 to AC bus 1. We get suit compressor light is now out. We get needle indication as the suit compressor begins to pressurize and begin to go to delta pressure that is nominal. So make sure the light is out. Make sure the suit compressor delta pressure is 0.7 to 0.9 psi. Again, small discrepancy. Simulator. Some things are just not going to be perfect until they get tweaked in development a little bit later on. Suit cabin delta pressure should be greater than plus 2.0 inlet pounds per hour of water. So here we don't show, obviously, greater than plus 2. In fact, there is not even a plus 2 on the gauge, so it would be pegged. We're very clearly not pegged. Completely nominal discrepancy. Don't worry about it. Rendezvous transponder power to off. Your S-band transponder can come back on, and thus completes this checklist. I hope that wasn't all too much of a data dump, but like I said, you just focus on getting the procedures down, doing everything right. So, thanks for stopping. Hope you enjoyed.